Okay, this is the general pictorial representation of what I just mentioned, right. The BIST controller, it contains the address generator, data generator and comparator. Like address generator and data generator will pump the data into the controls and address and data into the memory to the internal location, and then control logic will go, and then once you write it, we want to read from those address location to see that whatever written is coming or not. That is going to be compared in the comparator, and if there is a mismatch, that is when we say okay, the test is failing, means like memory is defective. Okay. Now this is a simple BIST control for us, right. But now how this BIST controller is controlled from the external world, external to the chip. Okay. That is where the tap will come to picture. So one of the important interface is tap, other one is direct IO, but generally direct IO generally do not use, because there will be hundreds of memories or thousands of memories in a design, and having interface, test interface for each of them is not practical, right. That is why they will all control through tap, test access port, what we discussed in the beginning, right. So this is the MBIST architecture, right. Generally so when the memories, if you see the right hand side, that is the memory. Just when you talk about simple memory, the memory interface is going to be controlled by the BIST controller, and BIST controller is going to be controlled by the tap. Okay. Now what are we doing here is, so to the memory there will be a functional interface already. Okay. Now we are going to, through the mux, we are going to mux the functional data through this BIST data, because the BIST controller now is going to generate this address and data, right. That data is going to be muxed with the functional data. So when you are in the MBIST mode, only the MBIST controller only will control the memory. Basically it will control the read write signals, it will control the clock, okay, it will control the all the read enable signals, and also output is taken, it will go to the functional logic also, but it also come back to the BIST controller, because we have to compare the data what is written, right. So that is where the comparator comes into picture.